Hello, in this video we're going to learn about how to show a biconditional. When the conclusion of an argument is a biconditional, how do we go about doing that? We know that we have different strategies for what you do when you're showing a letter. You make an indirect assumption and you box and cancel with ID or maybe with DD. When you're showing a negation, you would start with an indirect assumption. When you're showing a conditional, you would want to assume the antecedent and probably show the consequent and then use this for CD when you're done with the subderivation. To get a conjunction, in general, you can always show both of the two conjuncts and then put them together with ADJ. So we're going to have a strategy for biconditionals, and we're going to see what that looks like. And it's actually basically this conjunction strategy, because a biconditional is a conjunction of conditionals. So we're going to start with a relatively simple problem, and we're going to work our way up. We're going to start with 2.6 LRS 350. So our first line is going to be show conclusion. Now we could do assume ID, but that's not actually useful. The only thing right now we could do with this, well, if we got P if and only if Q, then we could do ID with these two, right? Because they contradict each other. It's a sentence and its negation. Good. But if we had 3, we could just do direct derivation. And so we don't need 2. 2 doesn't help us. So we're going to plunge right in without making an assumption, and we'll say premise 1, premise 2. And there is no premise 3. What we are aiming for is to get P if and only if Q. How are we going to do that? Well, we're aiming to do a direct derivation in this case. Well, what we want to do is build up P if and only if Q. Just like if we had a conjunction, if it was P and Q, what would we try to do? We would try to get P, we would try to get Q, and we would put them together with ADJ, and then we would say, direct derivation. Of course, this isn't going to work because this is not the conclusion of the argument, but that's the strategy we would take. So we're basically going to do something very similar with the biconditional. We're going to get if P then Q, we're going to get if Q then P, and then instead of 6, 7, ADJ, we're going to do 6, 7, CB, using our rule that says when you have two conditionals, you can put them together into the biconditional. And that's because 8 is really actually just if P then Q and if Q then P. This biconditional is just one way of thinking about it is that it's a more compact way of saying this. It's an abbreviation. These two are, in fact, are exactly equivalent. They always agree, always have the same truth value. So what we're going to do is basically just what we would do with conjunctions, except that we're going to go from two conditionals to the biconditional. Instead of saying 6, 7, ADJ, we're going to say 6, 7, CB. So we need to get these two and stick them together. Fortunately, we already have if P then Q because that's premise 1. So what we need to do is get if Q then P. We need to get premise 2. We need to get the other half of the biconditional and then just stick them together. When we look at this derivation, we can't apply any rules, and that means we need to do a subderivation. So what we should do is say show if Q then P, and that's what we're going to do. And we're going to be able to do that because actually, as it turns out, this... Oh, that's not what we want. That and that, these two sentences are actually equivalent. These two sentences always have the same truth value. So what we're going to do is just turn this into that, and then having these two, we'll stick them together with CB to build our conclusion. So we're going to now, once we introduce this show line then, we're not trying to show P if and only if Q anymore, we're trying to show if Q then P, and we should make an assumption, because whenever we can make a conditional assumption we want to, and we're going to say assume CD, giving us Q. What can we do with Q? Well, we can double negate it, and that lets us do modus tollens with 3 and 6, giving us negation, negation P, and we're then going to remove those double negations, giving us P, which is the consequent of what we're trying to show. We're trying to show 8. We're going to box and cancel by applying with line 8, because P is the consequent of that. And now we're basically done. We're just going to stick 2 and 4 together into the biconditional, and we're done. And that's it. Okay, so what we need to recognize here is just, okay, well, I want to do a direct derivation of this biconditional and use my CB rule, just like if it was a conjunction, I would get the two conjuncts. Well, I want to get, in effect, the two conjuncts of this, which are if P then Q and if Q then P. Lucky me, I already have if P then Q. I'll do a subderivation of if Q then P, and I'll stick them together using the CB rule, and then I have the conclusion, and that's a direct derivation. So that's the basic idea. Let's look at another example. So here we have our conclusion is again a biconditional if Q, if and only if P. We're not going to make any assumption. We're just going to try to do a direct derivation, but we're going to need to use subderivations. So we think, well, I have Q if and only if P. What I want to do is build that. And so what I want is if Q then P, and I want if P then Q. And once I have those, I'll be able to apply CB, our new biconditional rule, giving us the conclusion, allowing us to DD. And the only problem is, we don't have these. But once we get them, this is what we're going to do with them. So we want to get them. Now let's leave those. So what are we going to do? Well, we actually have so what we want to do is do subderivations of if Q then P and if P then Q. And this is such the sort of fundamental strategic approach with biconditionals that we have a new show command for them. We're going to say show cond for show the conditional that's part of our show line. Right on our initial show line, we have Q if and only if P, which has two conditionals as pieces. Show cond says, which one would you like to show? So we'll just choose the left to right one first, and then we'll do the right to left one. So we'll choose if Q then P first. So we type show cond, and that lets us choose one of the two conditionals that make up the biconditional. Okay, well, it's we're trying to show a conditional. Let's make a conditional assumption. Oh, well, we can put this together with 3. We'll say dn on 5, giving us not q. That's the negation of the consequent of 3, so we can do dn. We will eliminate those two double negations, giving us p, and that's the consequent of our show line, and we are done with our first subderivation. Now we need to do our second subderivation because we want both of them. So we'll say show cond again outside of the first subderivation, and this time we'll choose the second one. Let's go ahead and close this because we don't need it. We'll say assume CD again because we're trying to show a conditional. Oh, look, well, we can, if we get not P, then we have the negation of that, meaning we can do modus tollens. So let's get not P. Let's apply modus tollens to 2 and 12, giving us the negation of the antecedent. Let's remove those double negations, and we have the consequent of what we're trying to show. Keep using the wrong lines. And so, right, this is the consequent of that, so we can use this to box and cancel that with our CD rule. Close that up, and now we're just going to stick these together for 10 CB using the new conditional biconditional rule. We want Q if and only if P. This is the conclusion. Let's get rid of these excess lines, and we're done. So this is the general format of our deriving a biconditional, and it's what we have in our strategy document. So we say show the conclusion, and then we show each of the two pieces. We show the left to right piece, and we can use the show cond command for that. And then we show to enter that show line. And we'll make that conditional assumption there, and then the derivation proceeds how it does. We may use the premises in there. And then we'll do the, we'll show the other conditional, again, entering that show line with show conditional, and again, making that assumption. And once we've shown the two conditionals, once we've boxed and canceled those show lines and can use those show lines, then we put them together using CB, and that is a direct derivation. It's a matter of preference where the premises go. You could put them in between the first show line and the subderivation, or you can bring them into the subderivations. It's really entirely up to you how to do that. As it is with a conjunction. It just doesn't matter. You need to make sure you use them, but whether they go between 1 and 2 or you just stick them in the subderivations, that's a matter of taste. So that's what we want to do, and our guide on subderivations has that. We say what are our 3 main sort of subderivation strategies. We'll show cons if you're trying to show conditional, show conj if you're trying to show a conjunction, and now we have show cond if you're working on showing a biconditional. And these are all preferable to show unneg. So if when you want to look at your derivation and think, what's my main show line, and that tells you, oh well, I should use one of these. If you're not in a situation where any of these apply, if you're not trying to show a conditional, you're not trying to show a conjunction, or you're not trying to show a biconditional, then you want to think about doing show unneg, because at that point probably you will instead have the negation of a conjunction or the negation of a conditional, or as we will see, the negation of a biconditional. But when we're thinking about which subderivation to do, the priority is the first three, and only do show unneg if none of these strategies apply. So that's our subderivation, or that's our strategy for getting a biconditional. Do subderivations of the two pieces. And I will do another example in another video, but that's how this strategy works.